Hey y'all, it's Andrew here, and it is a Tidy Tuesday. And for this week, I believe we're doing a rap data set where I guess it comes from the BBC Music, and it contains, I guess, the voting for the best rappers. Okay, so we're gonna just do the normal thing and load in our data set. And I'm not sure what I want to do right now, but I think set. We're gonna load up the tidyverse. Tidyverse. Okay. So there's two main data sets, and so that basically has the Critic, and their top 5 rap songs of, I guess, of all time. Let me check it first. Um, yeah, so it's I guess it's like the best rappers. They also broke down the results into one definitive list, but also didn't just publish the best list. They also published the complete results and a description of the simple algorithm they ranked the songs. So they basically did some basic point system where first, if you were ranked 1, you got 10 points. If you ranked second, you get 8 points, and so on and so forth. Okay. So we got a polls thing where it actually has like the polling results. And then we have, what's it called? Rankings, which has just the overall rankings of that song. So Juicy is ranked 18 times. 9 times it was ranked number 1. Um, I I think we can do some things with the rankings, but I think a cool thing would be is to look at, I guess, the critics and the polls for that. Especially since each person is supposed to just name their 5 favorite or 5 best rap songs. It'd be kind of cool to do a recommendation engine, because that's what I've been doing for my capstone project, and I think a recommendation engine is pretty easy to implement, especially in R. So we're gonna first do a basic exploratory analysis on this. So let's just count the titles first and see which ones were just in the on a critic's top 5 list the most. So Juicy, Nothing But a G Thing, The Message, these are like the most popular songs. Additionally, I'm curious if there's like a kind of like a golden age of rap. So I'm gonna do just a count of the year. Okay, and then I'm gonna, I guess, plot it out. So ggplot year y equals n. So yeah, there kind of actually is a there is kind of a golden, to me there might be a golden age rap. So I'm gonna see if I can do something else with it. So I'm gonna say mutate. I guess it'd be, what was it? Decade equals year divided by, what is it, 10. So for it, and then times 10. I think that's how it works. Color equals decade. Oh, it's a fill. Mutate decade as that. And I gotta make this into a factor just to make sure. So decade wrong. Okay. Yeah, so I did that. That's and the thing is I am not that smart. This is just like a common way to round things off by like the decimal place. So it's a common thing that people use in, like, I guess, like SQL and stuff like that. So yeah, this is very popular to use to like basically cut off the mod of it. So yeah, we can see that there's like a golden age of decades, right? And just to reiterate the entire thing, we can kind of do almost an aggregated thing of it. So we can do, we can just fill out the decade. Boom. So I'm gonna write the golden age of rap is the 1990s, which is pretty cool. One thing that I think would be interesting to look at is, let's see here, polls. We should count just how many artists, like who's the most famous artist for it, for these things. So sort equals true. Notorious B.I.G., Wu-Tang Clan, Jay-Z. These are all pretty famous, I guess, 90s rappers. Who I would say definitely peaked in the 90s. Obviously Kendrick Lamar and Kanye West, I would say didn't peak in the 90s, especially Kanye West didn't peak in the 90s. And I think Kendrick Lamar didn't have any songs there. Okay, so I don't think, let me look at it first. Okay. Maybe I'll do a basic distribution of it. So I'll just say AS X equals 0, Y equals N, and then just a box plot. So some people are heavily in there, are heavily mentioned, and some people aren't. Usually they're only mentioned once. So just do a log transformation of it just to make it a little bit easier. I don't even think that's very good, so I might just do I might just filter n does not equal n is greater than 1. Okay. I'm just going to remove it, and we'll just remove that. Actually, sometimes when a box plot doesn't work because it's heavily skewed, I'll just do a geom density. Because it you can kind of just get a better feel of it. You can see that, oh, most of them are at 0. Cool. Another thing that I think would be interesting is like, oh, what about artists who have like, who are like they're like the top artists, but they're not the top of the top, right? So maybe they're mentioned a lot as like the number 5, but they're never like the top. Like their songs are never the most favorite songs, right? They're only kind of like my 5th favorite song artist. So we're gonna kind of do this aggregation of it. I gotta go back up and make sure what rankings. Okay, so rankings is like the actual rankings. Polls is from the Critic. So I'm gonna have to remember that. Select artist, and N1, N2, N3, N4, N5. There's definitely a better way to do that. You could say like contains N and artist, but it's not a big deal. Okay. Let's see here. I just want to make sure there's gonna be duplicates. Yep. Okay. So there's gonna be duplicates. So I think we can do what is it? A group by artist. Summarize. Is there a summarize all? And then we can say sum. Yes. Okay. So we kind of run into a few problems here. We can see that Tupac, Jesus, Tupac has some features, and we can either leave it in or just resolve it. And I think it depends on your perspective of, I guess, how you should be counting artists. Like, it's hard because what we're trying to do is equate an artist instead of an artist's songs. So we might just remove the features altogether. So that way they're just not mentioned because it's more of like a shared thing, and we want to look at everyone else. This is pretty arbitrary, so I'm gonna say str detect feature. It's artist feature. Okay, and so I just said art. So I said any string that's in the artist that has the word feature in it, we're gonna remove, or we're gonna say not, basically not. Okay. So I think that should resolve everything. Everything's good. Cool. Okay. Now let's just plot out ggplot as x equals. I want to see let's figure out a good way to visualize this. Like, who are let's just do basic filterings. Okay, so filter, or we can do top n, n5, n equals 3. Okay. So Grandmaster Flash and the Furious Five, Jay-Z, Kendrick Lamar. Oops, I'm gonna do a arrange by n5. So Kendrick Lamar, he's mentioned a lot as the 5. Actually, I got it. I got a better idea. Okay, so we're gonna do a GD plot, and we're gonna just show n1 and n5. Dope. Maybe we'll do a GM smooth just to see if there's any relationship. Okay. There is like so what it's saying is it can find a relationship, it can fit a line into it, but I don't know if it's actually an actual relationship, or it's just is able to fit a line. It's pretty easy to fit a line between points. So I'm gonna do GM jitter just to make sure if this point doesn't have any overlap. So there we go. We can see how most of it is centered around, okay, you either have a few top 5s or a few top best songs. So I'm gonna say rank 5 and rank 1 songs. The majority of the time you don't have it in the, say, like the upper right, where you have a lot of ranked 5 and ranked 1s. It's usually just concentrated to a small amount. So it's really extrapolating, and we don't really want this GM smooth function because it's not really a real relationship. We could also do maybe like a scale. Oops, what's that? Scale x square root maybe, and plus scale y square root, or maybe like log 10. I don't think that's right. Okay, we're not gonna do that. Okay. So now we actually want to look at we want to actually look at the guys who have like, let's just arrange by n1. Oops, descending order. Right, so Notorious B.I.G., he has the most like top favorite rank 1 songs. Same with Public Enemy and Wu-Tang Clan. They also have a lot of, not a lot. So like, for example, Public Enemy, like they have a lot of favorite songs that are like ranked 1, and only one time where their song was ranked on the bottom. Okay. So I'm going to actually do a slice. So we're going to just grab the first 5 people. And right here, we're going to do the same thing, but we're going to do descending over for n5. And now we can kind of look at it. And let's see if there's any duplicates. So Grandmaster Flash, he has like the most, they have the most, like one of the top 5 favorite songs, and also the bottom of it. So they have a lot of top 1s and a lot of top 5s. Whereas Kendrick Lamar, he has a lot of top rank 5s, but not a lot of rank 1s, which is kind of odd. Especially when you see how like the people who have the most ranked 5s, or the least favorite of the best, are I think a little bit more recent artists than the best of the best. So maybe these critics are only just kind of like romanticizing 90s, or maybe the 90s were just really the best age. You never know. So that's just like a basic kind of kind of like just a look at the songs that were actually used, or the songs that were considered as the best songs. But what we really want to look at is the polls for it. So we're going to look at polls. Okay. Critic country. Interesting. I wonder if critic country has anything to do with it. So we're going to just do a count critic country. Okay. So Germany is at 45. US is at 365. That's interesting. There's actually a decent mixture of it. I would expect way more, just like it would just be completely American centric. But okay, so country 2 is Kurdistan. So I think we can just ignore country 2, I guess. What I'm curious about is I wonder if there's like a discrepancy of uh of countries. So I wonder if like Canadian countries like Drake more than like Tupac, whereas like American, USA critics I don't know, someone else. So we're gonna do that. We're actually gonna go and count the titles. So count for every title. We're gonna count the critic country. Okay, and we'll just filter n is not equal 1, just to filter it out a little bit more. And then we'll do arrange by title. Okay, so most of it is by that. So I got an idea too. So count critic country, and we'll say the name equals name equals song nom. So that's like how many nominations did that title get? So we'll say did that song get? And then we'll also add a count of just like critic country. And no, we'll add a count for just the title. And that name will be number of countries. Right, so 99 till infinity has 2 countries and has been nominated 7 times, right, in total. Okay. So now we're going to filter where number of, we'll say, let's see here. Filter where number, of countries is equal to 1, right? So, and then we'll say filter, we'll say and critic country is not equal to US. And we see 83 of it, 83 rows. So 83, and we'll say n row, and then we'll say divide by n row of polls. So, okay, we'll say 15% of the polled, of the top songs were voted by only 1 country. So there could be like there's like a hometown / country bias, because if these critics are saying that these are the best songs of all time and these songs only get 1 vote, I would think that's a little suspicious. Okay, now I'm gonna keep on going and look at, let's do let's see here, song nomination by the country, song nom country, right? Because then it's like US does 6 times. Okay, now what I'm curious is let's see here, how can we figure out, I guess, the average. What I'm trying to figure out is, is there like, do countries vote relatively the same? So let's just do a ggplot of it. So a ggplot, no, we can't do a ggplot. Let's see here. Oh, we'll say filter number of countries does not equal 1. Okay. I'm gonna also say count title. Oh, count, no, we can't do that. We already did that. What else can we do? So number of countries. So most of the time, U.S. is the majority. Okay, I got an idea. So now we don't need it. So we'll say it's like minus. We'll deselect the number of countries, which I should change to a better thing. And then we'll do like maybe a pivot wider, names from equals critic country values from equals song nom country values fill list, and then we'll say song nom country equals 0. Okay. Actually, I think it's already in a form. Let me check it again. Yeah, we're fine with that. Okay, we'll just do a ggplot see what I kind of want though is kind of like a grouping to see how they react with each other. So I think I might have to do the pivot wider thing, and then ggplot it. Oh wait, no, I can just do a let's see here. I could probably do a ggplot x equals critic country, y equals song nom country, and then we'll say group equals title song nom y equals okay, there we go. And then we'll do okay. Not really what I wanted, and I think this doesn't really make any sense for what I'm trying to view. So I'm gonna scratch this entire visualization and do the pivot wider names from critic country values from song nom country. And now we just have 52, and I think we can kind of just compare. Man, I really want to. I think ggplot AES. There's definitely a good way to do this. I'm just not sure how I should do it though. Let's see here. Plus geom com plus maybe I do a facet grid for rows equals vars title, no, vars critic equals vars critic country, and then calls equals vars critic critic country. Okay, no, we'll do, yeah. Maybe I'll do calls. Nope. Okay, I don't like any of this. I think this, yeah, it's fine. We kind of look at the dis. We'll just throw it like that. I'm trying to, I could spend like a decent amount of time on this, but I don't really need to. So we're just gonna ignore that. That's fine. The big thing that we're actually trying to look at is the actual recommendation for each critic name. So we're gonna do that first. So we're gonna do polls, and we're gonna select critic name, title, rank. Okay. And the ranking, I believe the ranking is through, like, if you're ranked 1, rank 1 is the best, right? Yes, first rank track. So what I'm gonna do is, okay, for the recommendation engine, what we're gonna have to do is process it into a matrix. So what I'm trying to decide is, do I want to evaluate this as a ratings matrix or a binary matrix? And the reason is, technically these ranks do have, they could be perceived as almost stars, right? Where it's a 1 is essentially a 5-star ranking, and a 5 is a lower star. However, lower stars in the context of a recommendation engine is bad. However, these are the top 5 songs. So just because you get a rank 5 on a song means you're just like the 5th favorite, which isn't exactly the same thing as ranking something as rating something like a movie, like on Netflix. So what I'm thinking about doing is changing this rank into basically a binary matrix where you're basically able to choose 5 songs, and then those are the 5 songs, and they have basically relatively the same weight, because I want to be able to have someone rate, basically choose 5 of their favorite rap songs in this list, and have it recommend some more, like 5 other songs that you might want to listen to. So that's what we're gonna do. We're gonna say n equals 1. And I'm gonna remove the rank. So what this is saying is, okay, all these values, they chose those values, right? So I can just do kind of like a really efficient way of just kind of making a binary matrix. There's probably a better way to do it, but this is the way that I kind of do it. So I'm gonna do a pivot wider, names from equals title, values from, and values fill list n equals 0. All right. Actually, I'm gonna do arrange title just to make it a little cleaner. Okay, so what it's saying is, all the names from this title, like all the values from the title will be columns. And we're gonna fill up each column with n, which we gave it, which was a 1. And if you don't have that n, so for example, Philip Casors didn't have a 1 for 22 twos, we're just gonna fill that with a 0 and 7 NA, like this one. So now we have our binary matrix. So we're gonna call this we'll call this wrap matrix. Okay, and we're gonna actually load up a different package called Recommenderlab. And what Recommenderlab needs is actually, we gotta convert our wrap matrix into an actual matrix. So as.matrix. And we're gonna have to convert it to a binary rating matrix. Oops, where is it? As binary rating matrix. Map df as.numer. Oh wait, just that. There we go. Oops. It's in 0s and 1s, right? Oh yeah, I gotta deselect the critic name. Boom, and it creates a matrix. So I'm gonna call this wrap. I'm actually gonna put this guy right there, and I'll put this guy right there. Okay. So we create our wrap matrix, and then we're gonna have to do it. Was it an evaluation scheme? So what's cool about Recommenderlab is Recommenderlab Lab. They have a bunch of like pre-made function into it, and it's actually not a lot of functions either. So it's a pretty uh simple thing. They're just recommender, uh, and I guess and then like you have to do a schema, right? So first we have to create a scheme. We give it our data, so we'll say wrap matrix. We give it a method too, so method equals, and there's two main collaborative filtering methods. There's UBCF and IBCF. We're gonna do UBCF first. Given equals, and we'll say given equals 4. Oh, whoa, what's going on here? I'm gonna look at it first. I always get confused by the naming conventions for these functions. Data method split. Okay, there we go. So this is the actual like training schema. So we'll call this training schema evaluation scheme. Oh my. Scheme, and our data is our wrap matrix, and then we'll say our method will be, we'll just do a split, so we'll do like an 80-20, and they say train equals 0.8, and then we also give we also give it a given, which is like the number of items we're going to give it, and we'll say all but one. So how to do all but one is k equals minus 1. Given equals minus 1. So we're going to give it all the data besides 1, and I'm going to have it predict it. So for example, if we look at our polls, we would probably just take out these first 4 and have it try to predict times up. Okay. So we have our training schema, right? Evaluation scheme using all but one items, train split with 1 time, good ratings, NA. Since it's a binary rating matrix, there's no such thing as good rating. It's just whether you bought it or not. Okay. And then I think it's the evaluate, right? I'm not going crazy now. Evaluate. Yes. So this is a thing that I switched around with evaluation scheme and evaluate. So now we're going to train up a UBCF model. So evaluate, and then we get it a schema method, which will say method equals UBCF. And we'll say type equals top n list. Top n list is, we're just going to have it predict a certain amount of times. So we'll say n equals 5. Right? So we ran that model. It's going to look at that. And we'll also do an IBCF model. And the only thing you have to do is change to IBCF. And we train 2 models. So we can kind of look at our UBCF model too. By doing like average, we can find the average scores. So our TPR is 9%. So 9%, when trying to predict 5 items, 9% of the time it'll actually reach that one whole item, which is it's not great, right? But we'll just plot it out. Yeah, it's not great, but it's just a recommendation engine model. It's a recommendation engine. So if you look at like something like Amazon, most of the products they recommend you don't actually end up buying, or they're never very accurate because it's using basically a very fast engine to predict predicting the item that's in the entire product space. So there's really sacrificing predictive power for speed. But we can also look at our IBCF model. And yeah, we'll actually do, we'll evaluate average IBCF model average. So currently our UBCF model is much better than our IBCF model. However, we can also go and tune our model so we can actually establish certain parameters. So for UBCF, we have nearest neighbor. So I'm going to just do a function for this. Yeah, so we're going to say train, we'll say tune UBCF function and then parameters. Okay. So we're going to actually give it also a schema. So schema. Okay. And we should probably put it this first just to make it look a little bit better. Parameters. So given our schema, we're going to basically do what we already did, right? Because we're going to have it evaluate a UBCF model with the top end list with 5 predictions. However, this time we're going to give it our parameters. We're going to give it a list, and the parameters for this is nearest neighbor, which is NN. So NN equals parameters. Actually, we'll say tune tune engines and yeah, tune engines. So we have our UBCF model, and we'll just do our IBCF model too in this thing. In IBCF they use k nearest neighbors or something like that, so it's just k equals parameters. Okay, so we have that, and we'll do UBCF model average. Yeah, and we'll say let's see here, as dot data frame UBCF model, we'll say as table. Yeah, as table. Okay, so we'll say as table, and then we'll say mutate param equals parameters, right? And we'll do the same thing for the IBCF model. Okay, and yeah, we'll also say mutate param equals parameters and model equals UBCF, whereas this model will be IBCF. Okay. Okay, and then we're gonna just R-bind these two results. Okay. R-bind. I'm gonna clean this a little bit. So basically we're gonna train a model with these given parameters and return the average results. So that way we can just kind of do everything the easy way and not have to repeat all this code. We don't have to do this code over and over again. We can just kind of run it. I think you can pipe into a return. So we're gonna do that. Okay, so let's try it out. Tune engines. We'll give it our what is it? Our training schema. And our parameters equals parameters equals, we'll say 10. So you need to have 10 of your nearest critics. Boom, and it returns this. Parameters 10, our TPR is this. Okay. So what if we actually give it a list? 10, we'll do 5, 10, and 15. It doesn't work because you can't really give it a list. However, we actually can. So we'll say tune grid equals C 5, 10, 15. Okay, and then we'll say it. We'll say tune grid. We'll give it a tibble, and we'll say parameters equals C1, 5, 15. So we have our tune grid. Okay, and then we can just do mutate results equals map_df. .x is our parameters, and then our function is tune engines. Tune engines, and we give it a and then we just do tune engines, and we give it a trans. Oh my god, tune engines trans. What is it? Schema. What do you call it? Training schema. And we'll give it our training schema, and then param equals .x. Uh-oh. Neighbors, incorrect number of dimensions. Maybe we'll do 10. Let's just try map. .x. Was it parameters? Tune engines. Training schema. .x. Oh, I know why. Because we can't have 1, 3, 5, 10. Okay. We'll unnest the tibble. Boom, and we have all of this stuff. Right? So we have the given parameters. We actually didn't even need to add this parameter function. So I'm gonna probably delete that. I'm gonna delete this. Seems like a lot of work. Okay, so this time we'll do 3, 5, 10, 15, 20, 25. And we'll say history. Boom. So now we're kind of doing a grid search for the best nearest neighbor. It trains really fast because it's really just finding the distances, and it already has it as a matrix, so it's pretty easy to actually look at. Okay, so we're gonna evaluate the results. We're gonna ggplot it out. Y equals, we're gonna just go for every parameter. We're gonna look at the TPR, and we're gonna have the color equals to the model. And let's find the GM column. Fill. Was it nudge? Isn't nudge x equals true? How do I do that again? Let me go. Nudge column chart ggplot. Was it? Stat identity position. Prevent GM column stack. Position equals dodge. That's it. Okay. Position equals dodge. Okay. What do we see here? First of all, our parameters are not great. So I'm going to do label equals parameters plus GM text. Yes, x equals parameters, y equals TPR. Okay. I just added that just so I could figure out what these are. So we can see our highest TPR rate is 5 nearest neighbors using user-based collaborative filtering. User-based collaborative filtering appears to be the superior way to do it. IBCF kind of stays at this point no matter what. Although as we increase it to 25, it seems to increase its predictive power. But 5 looks like the sweet spot, so we're going to do 5, okay? So we're going to say use 5 nearest neighbors. Dope. Okay. So we're gonna make our final model. We'll just grab this up, and we'll say param equals list nearest neighbors equals 5. Okay, and then we can say what is it? Oops. We can evaluate our model. I forgot, isn't it evaluate UECF model method? Fuck. What is it? I gotta read it again. Okay, I figured out how to make the final model. I was actually using the wrong function. One of the biggest problems with, I guess, Recommenderlab is a lot of their functions are really unintuitive with their naming conventions, but this is how you create the final model. I gotta change the nearest neighbor thing. You're actually creating a recommender object, or actually a recommendation engine object. So if we look at our final model, we created a UBCF model learned for using 85 users. So since we finally did our tune search, our grid search for the best tuning parameters for our nearest neighbors and the best type of model, we can actually evaluate the model. So we're gonna say predict, and we're gonna give it, using our UBCF final model, we're gonna predict our kind of holdout set. So we use our training schema, and we say we're gonna predict, we're gonna give it the known data, or like 4 out of the 5 songs, and have it predict. Actually, I'm gonna just say a type equals top and list, just to make sure. So predictions, and then we can calculate the actual accuracy with calc prediction accuracy, get data, training schema. And this is actually the unknown songs that we're trying to predict with predictions. And we gave it all but 1. So equals given all but 1. What is it? Given predictions. What's going on here? Oh, I think I got an idea. Predictions goes right there. Given, it's right there. There we go. So our TPR is 9%. That's fine. That's kind of what we were expecting with our above graph. So lastly, we're gonna actually create our final model again. But this time we'll call it the rec engine. Recommender, get, and instead of using get data, we'll use our wrap matrix, or our binary ratings matrix from that was kind of the source for our actual schema. And we'll say our method is UBCF. Parameter is list of nearest neighbor with 5 nearest neighbors. And boom, we created our recommendation engine. So let's actually use our recommendation engine. We originally used all the polling data from it. So we'll just do polls, select title, distinct, and then arrange. Arrange by title. Okay. So I'm going to actually do my songs. So I'm going to poll, and I'm going to say SCR detect, and we'll say artist, and the pattern will be Kanye. Is it not artist? It's artist. String, artist, Kanye. Oh, filter. Okay, so Kanye, I'm gonna say we'll also say distinct title. I'm gonna say I like, let's see here. I'll say I like all of the lights. So I'm gonna say for mine, filter title is in, So I'm gonna say filter all the songs are in these things. So all of the lights is 1. Just make sure I typed in right. Yep. And then I'll say I like Chance the Rapper, even though I really don't like. Okay, I guess Chance the Rapper isn't in there. What else do I like? I'll do Kendrick Lamar. I'll be just kind of a huge Kendrick Lamar fan, so I'm gonna start a range title. I'm gonna say I like All Right. That's a good song. I like that song. I'm not gonna say it because this is a family show. Even though I'm not sure if you're like a little kid while you're watching this. I'm gonna do Mad City because I like that song too. What else do I want to look at? So I have 1, 2, 3, 4, and then I'll do one more. I'll say let's figure out what else. What other songs would I like? Oh, let's do a Tupac song. Tupac. So I'm gonna say I like Changes too. That's another song I like. Boom. So that's my order. I'm gonna just rbind, polls, select, title, distinct. Okay, so now we have all of it, and we'll say count, title, sort, equal count title, count title, and then we'll say mutate n equals n minus 1. So now what it's doing is basically converted all we have an order in there in the product matrix, and all orders that are actually all values are actually 1 are the things that I wanted into my my top 5 list. Cool. So then we just do a generic pivot wider, names from, the same thing, values from equals n, values fill, list n equals 0, right? So now we have it. If we notice, we should have where's changes at? Changes is a 1, right? As dot matrix, as binary rating matrix, and I'll say Andrew songs. Lastly, we're gonna just do the predict rec engine, and we'll say Andrew songs, right? And we'll say as dot data frame. As dot list, right? Oh, how do I table? Oh, how do I think as, and then I do that. There we go, as list, and then as dot data frame. Boom. So there we go. It actually predicted, I don't know, 10 songs, I guess. I thought I specifically said it's 5, but that's fine. So it predicted 10 songs that they think that I might like. Okay. So let's see if that makes any sense. So it says that I actually have heard Doo-Wop. I really like that song. And I do like Bodak Yellow. So the engine does work. This is not conclusive evidence at all, but to me it does kind of make sense. It is recommending things that are pretty relevant to me, but you also can tell that it's also not recommending a lot of accurate information, but it is recommending a decent amount of information. And if you think about it, for the given data that for what it was given, it was only using 107 users. It did recommend at least one useful song that I think I would like. So this is basically how to make a recommendation engine using Recommenderlab. It's pretty easy. A lot of the functions are pretty kind of unclear. However, there's a nice vignette on their site or their repo, so it's pretty easy to train up a recommendation engine pretty fast, and the pipeline is pretty straightforward. So I'll see you guys next week, and tidying on.